The question of Earth's age has been a topic of fascination and debate for centuries. How old is our planet? Is it just a few thousand years old? Or is it billions of years old? These questions have sparked heated discussions and shaped worldviews. In one corner we have young Earth creationists. They believe Earth is about 6,000 years old. This view is based on a literal interpretation of religious texts. In the other corner we have scientists. They argue that Earth is about 4.54 billion years old. This view is based on extensive research and evidence. The debate between these two perspectives has significant implications. It affects how we understand our planet's history. It influences our view of life's evolution. Our goal is to provide a clear, factual overview of this fascinating topic. Young Earth creationism is a belief held by some religious groups. It states that Earth was created by God about 6,000 years ago. This view is based on a literal interpretation of religious texts, particularly the Bible. Proponents argue that the world was created in 6 literal days. The 6,000-year figure comes from adding up the ages of people in biblical genealogies. This calculation was famously done by Bishop James Ussher in the 17th century. He concluded that Earth was created in 4004 BC. Young Earth creationists present several arguments for their view. They point to the complexity of life as evidence of intelligent design. They argue that the global flood described in Noah's story explains many geological features. They also claim that radiometric dating methods are unreliable. The scientific perspective on Earth's age is vastly different. Scientists estimate that Earth is about 4.54 billion years old. This figure is based on multiple lines of evidence. It's the result of over a century of research in geology, physics, and astronomy. The scientific community widely accepts this age. The idea of an ancient Earth isn't new. In the late 18th century, James Hutton proposed that Earth was extremely old. He based this on his observations of geological processes. Charles Darwin's theory of evolution also required an old Earth. It needed vast amounts of time for species to evolve. The development of radiometric dating was a game changer. This technique allows scientists to measure the age of rocks and minerals. It's based on the decay of radioactive isotopes. By measuring the ratios of parent and daughter isotopes, scientists can calculate ages. All these methods point to an Earth that's billions of years old. Rocks are like Earth's history books. They contain a wealth of information about our planet's past. Geologists have developed many methods to read this rocky record. These methods all point to an Earth that's far older than 6,000 years. One important piece of evidence is the principle of superposition. This states that in undisturbed rock layers, the oldest layers are at the bottom. Younger layers are deposited on top. Scientists have found rock formations with thousands of layers. These would take far more than 6,000 years to form. The Grand Canyon, for example, exposes rock layers that span nearly 2 billion years of Earth's history. Another line of evidence comes from plate tectonics. We know that Earth's continents move, but they move very slowly, only a few centimeters per year. Yet we see evidence of continents that have moved thousands of kilometers. This would take millions of years. The existence of mountain ranges also supports an old Earth. Mountains form through slow processes like plate collisions. Radiometric dating determines the age of rocks and minerals. Certain elements decay at a constant rate. This rate is called the half-life. It's the time for half of a radioactive isotope to decay. Measuring this ratio helps calculate a rock's age. Different methods use various isotope pairs. Uranium-lead dating is for very old rocks. It relies on uranium decaying into lead. One of the oldest rocks is from northwestern Canada. Zircon crystals from Western Australia are 4.4 billion years old. These ages match the oldest meteorites and the solar system's age. The age of Earth is closely tied to the age of our solar system and the universe. Astronomy provides compelling evidence for an ancient cosmos. This, in turn, supports the idea of an old Earth. One line of evidence comes from the most distant galaxies we can see. Light from these galaxies has traveled for billions of years to reach us. The Hubble Space Telescope has observed galaxies more than 13 billion light-years away. This means the universe must be at least that old. Another piece of evidence is the cosmic microwave background radiation. This is the afterglow of the Big Bang. It's been traveling through space for about 13.8 billion years. By studying its properties, scientists can determine the age of the universe. This age aligns well with other measurements and calculations. Stars also provide evidence for an old universe. We can calculate how long it takes for stars to form and evolve. Some stars, like red dwarfs, can live for tens of billions of years. The fossil record provides a window into Earth's past. It shows us the history of life on our planet. This record is incompatible with the idea of a young Earth. Instead, it supports the scientific view of an Earth that's billions of years old. Fossils are found in layers of sedimentary rock. The oldest fossils are found in the deepest layers. These are simple life forms like bacteria and algae. As we move up through the layers, we see more complex life forms appear. This progression takes place over millions of years. It shows the gradual evolution of life over time. This process is far too slow to fit into a 6,000-year time frame. Some of the oldest fossils ever found are stromatolites. These are layered structures created by bacteria. The oldest known stromatolites are about 3.5 billion years old. They're found in rocks in Western Australia. This means that life has existed on Earth for at least 3.5 billion years. That's far longer than the 6,000 years proposed by young Earth creationists. There are several common misconceptions about Earth's age. These often arise from misunderstandings about scientific methods. One common misconception is that radiometric dating is unreliable. But scientists are well aware of these potential issues. They use multiple dating methods to cross-check results. Decades of research have shown that radiometric dating is highly reliable. Another misconception is that the Grand Canyon formed quickly in a catastrophic flood. The Grand Canyon's formation is much more complex. The rock layers took millions of years to form. The canyon's shape and features are consistent with slow, long-term processes. When we compare the young Earth creationist view with the scientific perspective, we see stark differences. These differences go beyond just the age they propose for Earth. They involve fundamentally different approaches to understanding the world. The young Earth creationist view is based on a literal interpretation of religious texts. It starts with the conclusion that Earth is young and then tries to fit evidence into this framework. This approach often requires rejecting or reinterpreting large amounts of scientific evidence. It also proposes alternative explanations for geological and astronomical observations. These explanations often lack scientific support. The scientific view, on the other hand, is based on the scientific method. It starts with observations and evidence. Scientists form hypotheses and test them. They revise their ideas based on new evidence. The current understanding of Earth's age is the result of centuries of research and discovery. It's supported by multiple lines of evidence from different fields of study. The debate over Earth's age isn't just academic. It has real-world impacts on society and education. The beliefs people hold about Earth's age can influence their views on other scientific topics. It can affect how they understand issues like climate change or biodiversity. In education, the debate sometimes leads to controversies over science curricula. Some advocates of young Earth creationism push for it to be taught alongside evolution in science classes. They argue for teaching the controversy, but the scientific community overwhelmingly rejects this idea. They point out that young Earth creationism is not a scientific theory. It doesn't follow the scientific method or make testable predictions. The belief in a young Earth can also affect environmental policies. If someone believes Earth is only 6,000 years old, they might be less likely to accept long-term climate data. This could influence their support for environmental protection measures. As we've explored, the question of Earth's age has been a subject of intense debate. We've looked at two main perspectives: the young Earth creationist view and the scientific view. We've examined the evidence and arguments presented by both sides. The scientific evidence overwhelmingly supports the view that Earth is about 4.54 billion years old. This conclusion is based on multiple lines of evidence from geology, physics, astronomy, and biology. These different fields of study, using different methods, all point to an ancient Earth. The consistency of these results gives scientists high confidence in this age estimate. The young Earth creationist view, while held sincerely by many people, lacks scientific support. It requires rejecting large amounts of scientific evidence. While faith is a personal matter, the claim of a 6,000-year-old Earth is not supported by scientific evidence. In conclusion, based on the best available scientific evidence, the Earth is approximately 4.54 billion years old.